Welcome to video 8, Crossing Over. Thank you for taking time out of your 3-day weekend to watch this. I'll try to make it as short and sweet as possible so you don't have to watch too long. Now I know this is repetitive, but we're going to go over fertilization one more time just so that we can hit home how interesting this concept actually is. So a 23 chromosome haploid sperm, so because haploid means 23, right? 23 chromosomes, and a 23 chromosome haploid egg join together to make a diploid zygote, which has 46 chromosomes. So if you do the math, 23 plus 23 equals 46, which means you get half your chromosomes from your dad and half of your chromosomes from your mom. So if all of my siblings get 23 chromosomes from my mom and 23 chromosomes from my dad, like all of them get the same from the same two parents, how is it possible that we all look so different? Like, I obviously don't have those guns that my little brother has, or that, I don't know, she has some like weird teeth going on. And my brother, older brother, I don't know what's wrong with his, that look. Anyways, point being, like, how is there so much genetic diversity possible, like, to have 4 different kinds of siblings? And I'm sure some of you have even more siblings that look totally different from each other, from only 2 parents. Now, there are a couple reasons for this. First one, we've actually already encountered. So remember that activity we did this week, where we had the playing cards and we had to line up and try to act out meiosis? When you lined up in metaphase in your homologous chromosome pairs, like, it was really random where you lined up. Like, you could have been here, 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 and every time, you probably, at the end of this thing, you ended up with a different group of people. Like, in here, you would have had, different people, every cell that you were in. So you would look around, and sometimes you would have more spades in your group than diamonds. Sometimes you might have more diamonds than others, but you probably didn't have the same people in your group every time. So that creates a lot of diversity. But there's also another reason, which happened before metaphase, actually in prophase. It's called crossing over. Now, this is a new concept. Make sure you write that down in your notes, crossing over. But before we want to go over crossing over, we need to do a little bit of recap about our terminology here. So in prophase 1, sister chromatids pair up with the homologous chromosome. So sister chromatids, oh no. Okay, sorry. Sister chromatids pair up with homologous chromosomes, so this one and this one are homologous to each other, right? And then together they form a tetrad. That's a tetrad. So 4 homologous chromosomes together, so 2 sister chromatid pairs together, make a tetrad. And by these tetrads being next to each other, they're able to perform this thing called crossing over. Crossing over is a process where there's exchange of genetic material between homologous chromosomes. Now, what does that actually mean? The exchange of genetic material. Like, how do you exchange genetic material? It's actually pretty simple if you really look at it. Okay, so you have a homologous pair here. This guy and this guy, they're homologous. What happens is that the pink here is going to donate, its leg to the blue one here, blue guy here, and blue guy is going to donate part of its chromosome to the pink guy here. So in the end, you get these 2 different chromosomes. Now, let's review some terms again. We just talked about how the 4 pair of homologous chromosomes is called a tetrad. This new place that they exchange genetic information is called a chiasma. And recombinant chromosomes are the name of the chromosomes that are recombined to make a new chromosome. So see how this guy here is no longer the same as this guy where he started. He actually has this pink area right here. So it's kind of like in that meiosis activity, if I were like to break off one of your arms and give it to your partner and break off their arm and give it to to you, so then you would have exchanged arms. It's kind of that like that. You just break off a part of a chromosome and exchange it between the homologous pairs. Now the sister chromatids, these are still sister chromatids, but they're not really identical anymore. So to review, crossing over occurs in prophase 1 of meiosis, so when the homologous pairs first come together. And the genes will cross over to make new chromosomes that increase genetic variation. So the homologous pairs are going to exchange information to make 4 different chromosomes. I hope that wasn't too difficult. So I'm going to leave you with this. So these are honeybees. They're part of a insect family called Hymenoptera. And a Hymenoptera are really interesting because they have a lot of crossing over events, like a lot, like 10, 100 times, I'm not exactly sure how many times of what we do, but a lot. And the reason being is that they want to increase diversity, a lot of diversity in their worker bees, so they have workers that do different things and are able to do different things and have different traits. So the more diversity they have in their workers, the better their colony is. Interesting, right? All right, don't forget to do your comment on this video or write a question, and don't forget to do the Edmodo quiz. See you on Monday or Tuesday.